Hey everyone, and welcome to CS121, lecture number 14. In this lecture, we're going to be talking about iterators. Iterators are what we use to access elements in a container, usually a data structure. Whether that's a vector of elements you want to go through or a collection of key-value pairs in a map, an iterator is something that we can use to iterate over each element. An iteration actually happens to be something you've already seen before. Say we have this vector of ints here. The most common way to iterate through it is by using the standard for loop, where we declare an int I to keep track of the index and access an element at that particular index at every iteration, and increment that index at each iteration until we get to the end of the vector. Now, if we don't need to track the index I, we can alternatively write this in a much cleaner and simpler way using the range-based for loop. It's another way, and often my preferred way, to iterate over all the elements in a container. So we introduced this range-based for loop to y'all before, but we never really explained how it works under the hood. So how does the syntax work? We know we can use range-based for loops for both vectors and maps. So is there something about vectors and maps that allows us to iterate through all of their elements in this way? The answer is yes. Vectors, maps, and other containers in the standard library in C++ provide two functions, begin and end, which both return an iterator. Iterators are what are used under the hood for these range-based for loops. So the begin function returns an iterator pointing to the first element. And we use these two colons here to indicate that begin and end are member functions of some container, like the vector class or the map class. So what that means is that we'd be able to use dot notation to invoke the begin function and the end function on a particular container. So in this case, vector dot begin or vector dot end gives us the iterator specifically for the particular vector object or instance that we're iterating over. So you can see here that begin returns an iterator pointing to the first element, whereas the end function returns an iterator pointing not to the last element, but to the element after the last element, represented by this dotted box here. So for a concrete example, let's look at this vector here, which we'll call digits. So if I call digits.begin, then I can assign that to an iterator, which I'll name it. And this iterator kind of acts like a pointer. So you can see how the iterator returned by begin points to the first element in the vector. Now, there are some operators that are defined that we can use on iterators. The first being the increment operator, or the plus plus. What that does is it moves the iterator to point to the next element. We can also check for equality between two iterators using the double equal sign. And the star is the dereferencing operator. So in other words, we can access the element that that iterator is pointing to, much like raw pointers. So let's try incrementing the it variable here and see what happens. So it++ moves the iterator to point now to the second element in the vector. And if I dereference it, I would get the value 1. So now we can demystify the range-based for loop and see what is happening under the hood. This magical piece of code relies on iterators and is a shorthand equivalent to this for loop, where we start at the beginning of the vector using the .begin member function, and we increment that iterator to the next element at every iteration using the plus plus. We'll keep iterating through elements for as long as the iterator is not equal to .end, which is the element after the last. So this condition actually guarantees that we see every element in the vector. So you might be wondering why we need to use an iterator explicitly in our code when we already know about this range-based for loop, and we can write it in a much more readable and clean way than this really verbose version using an iterator. So for a vector, that might be true because vectors allow us to easily index into each element with a very straightforward indexing system. But not all Containers or data structures might have a simple index system, just like a vector would, or they might not be ordered in the same way that a vector is. So accessing the elements inside of something like a more complicated data structure like a graph or a tree might not be as straightforward. So for cases like this, like these two data structures here, we might store data in them, and we might also want to iterate over all the elements in these structures just like we would a vector. But it's not so clear how we would start. There's no clear ordering to these elements, and there's no indexing system. So using an iterator as a way to abstract away the underlying implementation of these potentially massive and complicated data structures is one of the reasons that iterators are so powerful. We can use an iterator and know that we can keep on incrementing that iterator with ++ to get to the next element. So no matter how complicated the structure we're iterating over is, we know that we'll be able to access each element within it.